So let's take a look at recreating a stock assembly with top-down design. So here we have an assembly of a sheet metal punch and hole flange former. So this is the punch part of it where you could tighten this down on sheet and it could punch a hole through it with a starting hole that's big enough for this bolt, and then reassemble this in this configuration with the sheet here. And when you tighten this down on it, it will form a flange around that hole in the sheet, which stiffens the hole. And you could find that often in aircraft, for instance, webs, if it's sheet metal webs of beams. If you want to just create some holes that lighten the beam and stiffen those holes, stiffen the whole web with those flanges. And then of course you can pass like systems like and wires and hoses through those holes. So in real life, this is what they look like, and this is the type of hole and flange they make. And here's an up-close view of it. So in SolidWorks, you can even use the finished part as a sheet metal form tool. So let's say we have part, just a flat piece of sheet. Let's see, it's 10 thou. We can use a forming tool based on that part from that assembly and apply it to our designs to other parts, and this is what the result will be. So you might ask, why would this assembly be top down? Well, if we take a look at the cross section, so let's take a look from here, and if we lower this down, we can see that they don't exactly have the same profile here. So even if we design the first one, let's say we know this will be 45 degrees, something like that, and then we make a tangent curve to the flat area of where the sheet will be. We don't really want to use the exact same profile on the top one, because when it's pressed together, we need it to have a consistent gap the whole way through. So this is a good example of where we might want to use assembly geometry to define how two parts fit together in relation to each other. So we can see each of the parts here in this assembly has this dash and arrow here, and that means that there's external references to that part. And so these parts are each referring to something to take their shape. And in this case, it's not actually in this assembly, because in top-down design, you can't really have parts be unconstrained like this flexible assembly here. So in this case, this assembly is just for demonstration. The actual assembly that generates these parts is another one here, where here these parts are all locked together, and we have construction geometry that defines the geometry of each one of the parts. So construction geometry or assembly geometry, I mean, in this case, we could have put it on the actual assembly front plane, or we could have a part that contains all the assembly geometry that isn't actually a part that we would build, but it might contain wireframe and surfaces to define the shape of the other parts. So obviously in SolidWorks we can't have surfaces at the assembly level. They have to be in a part. So I've put the assembly geometry in this case in a part, but if it's just wireframe, you can also put it in the assembly. So we can see here this part is independent, and each of these parts has a reference. So how does that work here? If we were to hide all of these, so we could start our assembly by putting in this part, mating it into position so it's fully constrained, and creating this sketch where this is really the main reason here why we're doing a top-down design, because we can assure that there's a, in this case, a 10 thou gap between, so it's here and it's all the way through here and all the way through here is 10 thou with these tangencies. And I mean, you can see these points aren't completely vertical to each other, so it's not the same profile. But when the sheet bends and you apply complete pressure on the forming tools, then the sheet will fit nicely in here and not get bunched up or anything like that. So then the next step would be, in this assembly, you would insert a part and mate it to the assembly. And then, let's say, in its front plane. Oh, so this is a good warning here that SOLIDWORKS provides, which is, so I'm trying to edit this part here, but I've started a sketch at the assembly level on this part's plane. So it's giving you a warning that you're not actually editing this part. So if you want to edit in context, you have to go to the assembly, edit the front plane, and then I can take geometry from there, so I can refer to it, let's say, with lines like that, or I can even project them in even though they're within the same plane. It's sort of like copying them in. And in the end, so we can create this part here that has that sketch revolved. And same with here, where it's referring to the lower portion. And as long as I don't move these in the assembly, they will keep that shape. And then these two are also generated by that assembly. So that's an example where top-down design can make things quick and easy to get a relation between the way parts fit together and the shape of those individual parts defined by the overall assembly fit. Now, the way that we created this flexible assembly is by just creating a new assembly and importing these parts the way that they were saved from the other assembly and mating them into position in a way that they can move. So this assembly is not defining their shape. This assembly is an additional assembly that just lets us move them around, and this assembly won't change their shape. So how is that happening? Well, this assembly is the generating assembly. So you can notice if I close that one, in here, if I do Control Q to reload everything, you can see that these parts know that they have an external reference, but there's a question mark there, which means they're out of context. So that means that they don't know if someone else or you has opened the other assembly, the generating assembly, and edited that one and then closed it and then reopened this one. It won't have updated these because they don't know they can't keep track of that while they're not open. So generally, we don't want to see these in an assembly. There are exceptions, which I'll go through in another video in this series. But in this case, if we just open up the generating assembly, and then this defines the context of those parts. If we go back to to this flexible assembly and just press Control Q to update everything. Now it realizes that, okay, I can sense that the context that is generating these parts is up to date and the references are open, so that question mark goes away. So that's an example of using a top-down assembly approach to create the shape of parts in an assembly. And in the next video, we're going to take a look at some more involved examples, some aircraft assemblies, and then we're going to take a look at some general rules, sort of guidelines that we can follow to keep well using this approach.